Ba-da-ba-ba-ba. You're loving it. Calculus edition.
Yeah, you heard calculus style. All right, here we go, guys. Let's get right into it. Let's get into today's episode. I'm hoping you're loving it. Okay, let's start. All right, so today's topic is L'Hopital's rule, guys. So pretty much you're going to be doing L'Hopital's rule if it's indeterminate form. So let's plug in a 0 first. E to the 0 minus 1, that's 1 minus 1, so you get a 0 in the numerator. And in the denominator, if I plug in a 0 in for x, ln of 1 is 0, and I get a 0 in the denominator. Because I have 0 over 0, I can use L'Hopital. So I'm going to use L'Hopital rule. So I'm going to take a derivative in the numerator. The derivative of the numerator is e to the x, so limit as x approaches 0 of e to the x over, and the derivative of the denominator is, let's see, 10 times the derivative of ln is 1 over 1 plus x times 1. So there it is. And now I can do direct substitution. If I plug in a 0, I get e to the 0, which is 1. And if I plug in a 0 on the bottom, I get 10. So the answer is 1/10. Let's continue on this one, guys. Yes, I know that you can do this by doing the difference of cubes, but the whole thing is L'Hopital's rule, so let's do L'Hopital's. If I plug in a 5, I get 0 over 0, so again, this is indeterminate form. So I'm going to take a derivative. Limit as x approaches 5, the derivative of the numerator is 1, the derivative of the denominator is 3x squared. I'm going to plug in a 5, 5 squared is 25, 25 times 3 is 75. So, why did it do that? So, 1 over 75. All right, let's continue. If I plug in a 0 for arctan of 0 is 0. And then if I plug in a 0 for x, well, that's still 0. So I'm going to be taking a derivative, guys. So limit as x approaches 0. The derivative of arctan is, let's see, 3 times 1 over 1 plus x squared times 1. All over the derivative of x is 1. So now I can plug in a 0. If I plug in a 0 in for x squared, you get 1 over 1 times 3. So you get just 3. Hopefully you're loving it. Okay. Continuing, if I plug in a 0, I get a 1 there, minus 2, so 0 on the top. If I plug in a 0, I get a 1 for cosine, so 1 minus 1. So again, I get 0 over 0. That is indeterminate form. So I'm going to take a derivative. Limit as x approaches 0 of e to the x plus, let's see, a negative e to the negative x all over the derivative of cosine is a negative sign, but I have a negative there. So 10 sine 10x. And now if I plug in a 0, let's see, if I plug in a 0, I get 1 minus 1. And if I plug in a 0 again, so I get 0 over 0. So again, try it again. So limit as x approaches 0, the derivative of e to the x is e to the x. And the derivative of negative e to the negative x is going to be a positive e to the negative x. Over, let's see, 10 times 10 is 100. 100 cosine of 10x. So now let's try it. If I plug in a 0, 0 and 0, I get a 2 in the numerator. If I plug in a 0 for x, I get 1 times 100, so 2 over 100, which reduces to 1 over 50. All right, let's continue. Calculate the derivative here. If I plug in a 0, okay, so notice that if you plug in a 0, I get 6 plus 0 minus 6. And if I plug in a 0, I get 0, so 0 over 0. So L'Hopital's rule. So here we go. Limit as x approaches 0 of 6 minus 6e to the x over, and I guess we're going to have to do product rule down here, guys. First times root of the second plus second times root of the first. And let's see if we get 0 again. If I plug in a 0, I get 6 minus 6, which is 0. And if I plug in a 0 down here, this is 0. And so I get a 0 again. So we're going to have to do L'Hopital's rule one more time. One more time. All right, so here we go. Limit x approaches 0. The derivative of negative 6e to the negative x is negative 6e to the x over, and I guess I'm going to have to do a product rule with this guy right here. So first times root of the second plus second, root of the first, and I still have this guy, so I'm going to have to do product rule again, guys. Well, actually, no, I can just distribute this to e to the x minus 2. So then just do the derivative of that, plus 2 e to the x. So there it is. So now I can do direct substitution, and if I do direct substitution, I get negative 6 over, let's see, this cancels out because I get 0, and I get 2 of those, so 2 plus 2, 4. So negative 3 over 2. All right, let's plug in, guys. If I plug in a 0, I get 0 minus 0. So 0, and if I plug in a 0, I get a 0, so L'Hopital. So here we go, derivative. Limit as x approaches 0, 3 minus 3, 1 over 1 plus x squared, over 2 minus, derivative of a sign is cosine, so 2 minus 2 cosine x. If I plug in a 0, I get 0 over 0. So, one more time. There's a song, you probably never heard of it. It's by Daft Punk. It's called One More Time. But yeah, okay, sorry guys. Here, let's continue. Do another derivative. I'm going to do a derivative of this guy right here. So, let's see. I'm going to rewrite this. 3 over 1 plus x squared. So limit as x approaches 0, I'm going to 3, 1 plus x squared to the negative 1. All right, so derivative. So negative 3, 1 plus x squared to the negative 2 times 2x. That's chain rule. All over, and then the derivative of negative 2 cosine x is going to be positive 2 sine x. So now, let's see. Yeah, we're going to have to do another derivative, guys. So here's what I have. Negative 6x over... Yeah, I'm going to bring this down. Over 1 plus x squared squared 2 sine x. If I plug in a 0, I get 0 over 0. So I'm going to have to do it one more time. So notice I'm going to leave the negative 6x up there, and I'm just going to do a product rule with this guy down here like this. So here we go. Negative 6 over, and I'm just going to do a product rule right there. So let's see, 2 times 2. So first, times root of the second, the root of a sine x is cosine x, plus second sine x times root of the first. 4, 1 plus x squared times 2x. So there it is. And all over, so now, and I still have the word limit in the front. So if I do that, guys, so no, now notice in the top I just have negative 6. If I plug in a 0, all this goes away. So if I plug in a 0, cosine of 0 is 1. 0 plus 1 is 1. 1 squared is 1. 1 times 2 is 2. So negative 3. All right, let's continue. So if I do direct substitution on this guy, I'm going to get 0 over 0. So I'm going to have to do derivative. So here we go. Limit as x approaches 0 of 3, 1 over 1 plus x squared times 5, 1 over 1 plus 2x squared times 2. So there's a 2 right there. So now, if I do direct substitution, which now I can, I have 3 over, let's see, I have 2 here, 2, wait, 0, no, that's a 0 because I'm plugging in x equals 0. 0 squared is 0, 0 plus 1 is 1, 5 times 2 is 10. So 3/10. All right. On this one, this is not okay, at first glance, it looks like it's L'Hopital's because you do get infinity over infinity, but just use end behavior. Use end behavior. So look, in the top, the end behavior is limit x approaches infinity, I get 3x. And on the bottom, you have 5x squared. So the bottom grows faster than the top, so this equals 0. And there it is. That's it, guys. I guess you could do L'Hopital's rule if you really wanted to, because you do get infinity over infinity. But I think it's just easier to just do it that way. All right, on this one you gotta have to be smart, or it's a little tricky. So we're gonna have to do watch. So check it out, guys. So you can't bring this down. Well, first of all, can you use L'Hopital's rule? If I plug in a 1, you get 1 and then 7. 1 minus 1 is 0. So you get like 1 over to raise to the power infinity, and that is an indeterminate form. So we're going to take a derivative. And before we do that, I'm going to say y equals x to the power 7 over x minus 1. So I'm going to take ln. I'm going to differentiate this because I want to bring this down. So I have ln y equals, 7x minus 1 ln x. So I'm going to say that's the same thing as saying ln x divided by, x minus 1 over 7. See, keep, change, flip, and you'll get this right here. So now I'm going to go ahead and find that. Limit, I'm going to take the derivative. The derivative of ln x is 1 over x. And the derivative of this guy, that's like x over 7. So I'm going to say that is 1/7. So I have limit as x approaches 1 of 7 over x. So I get 7. But remember, this is not what I had. Like this is, you have, that's, now you have ln of y equals that. So this is like saying ln y equals 7. What you want to do is get y by itself. So how do you do that? E. So now you get y equals e to the 7th. So there it is. All right, guys, here we go. We got 2 more questions. Sorry about that little break there. Bless you. No, it's okay. All right, so here we go. So if I plug in a 0, I get 11 over 0 minus 11 over 0, which is like infinity minus infinity. That is an indeterminate form. So I'm going to take before, you have a fraction minus a fraction. What you want to do, guys, is have one fraction. You don't want to have something minus something, even though that is an indeterminate form. But the best way to do this is to get a common denominator. So I'm going to multiply this one by x over x, and this one by ln of 1 plus x over ln of 1 plus x. And I'm going to check this if it's still an indeterminate form. So here's what I have. I have 11x over x ln of 1 plus x minus 11 ln of 1 plus x over x ln of 1 plus x. When I combine these, so here's what we're going to have. Limit as x approaches 0 of 11x minus 11 ln of 1 plus x all over x ln of 1 plus x. Now notice, if I plug in a 0, I get 0 over 0. So I can still use L'Hopital's rule. So I take a derivative, and we're going to have, the derivative of 11x is 11. And then the derivative of this guy here is going to be 11 over 1 plus x all over, and I'm going to have to do product rule here, guys. First times derivative of the second, 1 over 1 plus x, plus second ln of 1 plus x times derivative of the first, which is 1. So what I want to do is I want to get a common denominator for my derivatives here. So limit as x approaches 0. I'm going to multiply this guy here by 1 plus x over 1 plus x. And I'm going to multiply this one here by 1 plus x over 1 plus x. So now I'm going to have this. 11 plus 11x when I distribute, minus 11 over 1 plus x over 1 plus x, and I guess plus 1 plus x ln of 1 plus x. And I think I did that right. So these cancel out. And notice, again, if I plug in a 0, I get 0 over, and it looks like I get a 0 again. So let me rewrite it. Limit as x approaches 0. And I have, let's see, 11 plus 11x minus 11 all over x plus, I'm going to distribute this 11 plus 1 plus x, guys. Plus 11, 1 plus x, plus x, 11, 1 plus x. Alright, so again, if I plug in a 0, I get 0 over 0. So I get to do it again. So I'm going to do L'Hopital's rule again. So now I have, let's see, the derivative of 11x is 11. So 11 over the derivative of x is 1, plus 1 over 1 plus x, plus product rule right here. First times rid of the second. 1 over 1 plus x, plus second rid of the first, ln of 1 plus x. Okay, now we're ready. I still have the word limit in the front. Limit as x approaches 0. So if I approach 0 on this, I'm going to get 11 in the top. And then here's 1, and then here's another 1, because that's a 0 here for x. And 1 plus 1 is 2. And then this will be 0, and then this will be 0. So 11 over 2. Alright, one more, guys. I'll try to do this in a different color. So as x approaches infinity, e to the infinity. So here's what I have. I have infinity raised to the power 0. That is an indeterminate form. So I can do L'Hopital's rule. So I'm gonna make it look like this first. We're gonna have to do logarithmic differentiation, guys. So here we go. ln. I'm not taking the derivative yet. I'm just figuring out what this is. Bring the 3 to the x to the forward, to the front. ln of e to the x plus 1. All right, let's take a derivative. So limit as x approaches infinity. Remember, I have an ln in the front, so this is not going to be my final answer. So before I continue, let me ln e to the x plus 1 over x. So notice if I plug in infinity, I get infinity over infinity, so I can do L'Hopital's rule. If I do the limit as x approaches infinity, I get infinity over infinity. Indeterminate form, L'Hopital's rule. So derivative, 1 over e to the x plus 1, that's an e, times e to the x all over 1. So notice, what am I missing something? Oh, that 3 should have been right there. Sorry, guys. So notice, limit as x approaches infinity of 3 e to the x over e to the x plus 1, end behavior. E to the x divided by e to the x is going to be 1, so I just get 3. But remember, I had ln in the front, so it's like saying this, ln of y equals 3. I don't want ln. This is just like the last question. I forgot what number it was. It's just like number 9. You want to get y by itself, guys. So y equals e to the third. So there it is. All right, guys. Hopefully you guys liked it.